Hi, design, a soulful suffer, a joyful journey. Hello to all my listeners. And my today's episode is going to be all about semiconductor facility design, which is a thing of today, it's a thing of now. Let's welcome today's guest, Mr. Nishant Goyal. He's an architect and he has tremendous experience in designing semiconductor facilities. So let's understand from him what goes into making semiconductor facilities, what are the nuances, the things to take care of, what kind of special skills you need to design such facilities. So, very warm welcome to our episode today.
Thank you, Manu, for having me here. And I hope I can share some meaningful insights with everyone enjoys listening to. So, yeah, I'm looking
Okay.
forward to it.
So, can you talk a little bit about the semiconductor facility building? How does it stand out from designing any other facility of a similar nature?
When I look at semiconductors from a design perspective, then two or three things come to my mind immediately regarding the facility that is to be provided. One is dust free, and it's not just dust free, it's also anti static. And uh, it's about the workflow and ensuring that the various levels of cleanliness are maintained. By cleanliness, I actually mean inside air quality parameters. So typically when we do a semiconductor plant, we will have a class 10,000 and a class 100,000 clean room. We even do facilities which have a higher calibrated clean room, but typically it's 10,000 and 100,000. And it's about ensuring that the indoor air quality stays the same and in a uniform manner.
Okay. And wouldn't that be the same for electronic industries as well? So, how do semiconductor factory or semiconductor manufacturing facility, how does that stand apart from any other sensitive electronic manufacturing?
So you're right. In electronic industries, we normally have 100,000 uh, calibrated clean room, but in
Okay.
semiconductors, it can go up to 10,000, 1,000, and things like that.
So, apart from the clean room, there's nothing else that is different in a semiconductor factory, or is it not like that?
So a semiconductor factory is like a corporate office.
Uh-huh.
You have these small machines. Of course, there are some large machines, but there are a lot of these small machines where we're sort of doing something, some specific process, much like someone is sitting on his desk and doing that little process and then passing it on to someone else who does another process, and then someone at the end assembles everything, packages it, QC, and sends it out. Now, each and every particular machine has its key features, its key parameters that are needed. And for the most important thing is cleanliness, and cleanliness is measured in nanometers now. It
Mhm.
is not just something which is dust free. Oh, it looks clean. It's about ensuring even a speck of hair can actually ruin my product. And so it's that level of calibration that we're getting to. Um, so so I'll take you through a rough design process. uh, we try and understand what the raw material is. Then that raw material has to be dedusted, it has to be quality checked, and then it's sort of stored in an area which is clean. So that's where my clean room starts. From there, I actually use pass boxes to transfer the material into the manufacturing area, which could be a class 10,000. And then I won't divulge in the exact machines because that would not be right for my clients. But then we have a series of machines which will actually work upon that fab or wafer or whatever it is and create the product. After that, it will go into a class 100,000 again, where it will be proof check, quality check. There's a few molding machines. There are different types of machines again, which will again work on that product. And then you have that little piece of semiconductor, which could go into your laptop, into your pen drive, into your car, um, whichever industry. I mean, today everything is driven by semiconductors because everything is electronic. So so that's how it works. Now, as a designer, when I look at it, uh, so this is like setting the parameters in place. When I look at it as an architect, for me it's about thresholds. For me, it's about ensuring that my space is efficient. So of course, efficiency is through the layout of the process, but in semiconductor factories, efficiency comes in from how I'm managing the services in my plant. So so let's say if you open the false ceiling or the puff panel, which you will see on the roof of a semiconductor manufacturing facility, you will see you will see a world of ducts, filters, pipes, utilities, etc., etc. And it's about ensuring the shortest distance
For
for
sure.
each facility
For
to,
sure. So
to
it's the
ensure
background. What goes
efficiency.
into the background of creating that sanitized box, if I may
Yes,
put
and
it in
that's
a
what we
very
do.
yeah.
That's what we do. That's what our role is. Not just from an aesthetic point of view. Aesthetics is of course important because it makes my building welcoming. It sort of creates a brand image when a visitor comes in or a customer comes in and visits my factory. It creates a brand to attract the right talent to come and work in my
For
factory.
sure.
It creates a pride and a space quality which people enjoy, which is the basics of an architect. But architecture for a semiconductor unit is much more.
So how important is it for one to have a previous experience of having designed, or how, if I'll rephrase my question, how does having an experience of previously designed, similar buildings helpful in, sort of putting up a new facility? Because I mean, I would like to believe that one semiconductor factory is not the same as the other, right? One
Yeah,
may be
absolutely.
manufacturing one kind of a semiconductor and the other may be the other kind.
Oh yeah, each so we learn from each project, and as we go forward, we start refining our the design skills. So, for example, we introduced a mezzanine concept in a previous project, and it's worked wonders for the efficiency. It's brought the cost down of all my low side equipment. It's made my it's made my system more efficient and also cut down on the high side requirements of each equipment because I've suddenly cut down the piping lengths to a bare minimum, and it's made access to the space above my clean room very simple and easy. So
Uh-huh.
maintenance is easy.
Mhm.
Uh, it's solved a lot of issues which we used to grapple with earlier. Similarly, in a project, we also experimented with having a lot of utilities going in the floor, but that didn't work out so well. I mean, at the end, we saw that while it did work, but it was not the right solution. Um, so with each project, you have some learnings of a positive nature, some of a negative nature. So experience is key here because we are talking about thousands of crores of investment that goes into setting up these plants. They're
Naturally.
expensive plants to set up. They're not like just a heavy machinery plant where you're just giving them the infrastructure. The Of course the infrastructure is there, but then the utilities, the services are highly calibrated and very expensive. So you want to be doing things right,
For
and for
sure.
that,
I'm sure
experience
that's
is
true
most
for all
important.
kinds of projects, though. And it's not just the semiconductor factory, which is, having previous experience is helpful. But since I am made to believe that you designed one of the first semiconductor manufacturing unit of the country. So how difficult was it to source the right kind of technicians or the kind of specialists to provide those efficient services for that building?
So I'll answer it in a different way. I don't think it was tough. The the actual the actual difficult part was to understand what to do exactly. And for that, of course, we did a lot of case studies, a lot of reading, a lot of research, a lot of firsts in terms of in terms of what should be the bouquet of equipments. Um, and a lot of it is common sense as well, because
Of
create
course.
thresholds. Of course, technology
Design
and
is common
equipments.
sense.
Yeah,
Architecture is common
yeah.
sense ultimately.
So technology and equipments and all these things are there to help you.
For
But
sure.
it's the story of the building that an architect has to develop, and that's the brief that which sort of ties all the consultants and the vendors and the contractors
So very
together.
interesting point you talked about the story of the project, right? So normally when we have any other kind of a building being designed, the story is usually guided by the context or by the theme or the aesthetics. But in such a hardcore functional building, precedents for which in India may be few, how do you evolve your story?
So in semiconductor units, our story has two layers.
Mhm.
One is, of course, the aesthetic and you could say the the externality of the stuff, which is very important because these are showcase buildings for our clients. Uh, the other is a very intrinsic story, and it could be as simple as doing research about the context. Let's say you had a cement plant nearby. Now there's going to be a lot of suspended particles in the air. So how does my building respond to that in terms of how do I effectively shield that those particles don't enter my building? Because if even a speck of that ash which is in the air enters, of course I can filter it out, but it's detrimental for my project. So for us, uh, the the internal story of how I'm not just the typical architecture of the building, but how I'm ensuring a more efficient, if I may use the word, clean space, so that I have a better indoor air quality, which stays the same in future during the life cycle of my project. Now I have the technology to do it, but I have to also ensure that my context is aligned. So we do a lot of thinking and a lot of research on what is there in the context, what is my dust sort of creating elements nearby, what is my suspended particles creating elements nearby, what is the kind of uh, how are we curating the personnel and the material journey into my clean room space, so that my clean room remains the best. So that's
Talk about uh, any of the challenges that you normally face when you design such a building in terms of design or in terms of uh, sort of okay, so this is one. I'll pack it here. The other is that when you collaborate with the client, how informed do you think is the client regarding the the built form itself, or what kind of questions do clients have usually? What is your experience over there, and how they can sort of, because there aren't, like I said, too many precedents to look at.
see clients are more focused on their process,
For
because
sure.
they are grappling uh, with identifying the right process, the right machines, the right equipment that will help them make the correct product.
Mhm.
The environment, the indoor air quality,
Yeah,
the the flow is our job. So they entrust that
of
responsibility on
course they
us.
have, but
Now when we start looking at that, we sort of have, we understand what machines they're going to buy, what, etc., etc. And a lot of them are very similar from one project to the other, but there are differences. Now it's all about ensuring the most efficient space, but also something which is scalable.
so
In
you keep talking about efficiency.
No, I'll talk about scalability as well, because at least the plants that we've done, the first phase actually has very few machines.
Um,
The second phase will have a few more of those
that's a
machines.
very interesting point.
And the third phase will be an actual scale up. It could actually mean that they need 5 times the process space that they need in the first two
No, very
phases,
very
because
interesting.
they're doing prototyping.
Yeah.
They are doing testing of the product. They are ensuring that the market will receive their product.
Yeah.
They can't suddenly go and buy a huge gamut of machines,
Yeah.
because it's a very niche industry,
So it's also modular, are you saying?
very modular.
Uh,
Now when it's modular, it's a big challenge for me, because I have to ensure that that whatever I'm designing is not just expandable or scalable, it also remains efficient, because I have this clean room space where the visitor has to
Can
be.
you define efficiency a little bit more in this context?
So how should I? So let's say we're doing a fact. We just completed a factory a year back, where we have done an approximate 30,000 square feet of the process hall, which is the clean room process hall. Of course, the built area on the floor is a lot higher, but the clean room itself is about 30,000 square feet. Now, in phase one, which the client is currently using, he actually needs only 4,000 square feet.
Uh-huh.
Phase two, he will make it about 10,000 square feet. In phase three, he will obviously need 30,000, but I think he will ask me to build another 30,000 for him.
Uh-huh.
That's how the difference will be from phase two to phase three. Now, when he is doing expanding to phase two and expanding to phase three, please remember that the phase one will keep operational.
Uh-huh.
So my clean room air quality has to remain perfect.
Mhm. Which means you have to probably design all the ancillary.
Which actually means that I have to take a decision of what I can put at that time and what I have to put plan today.
Uh-huh.
Because if I start ripping up wall ceilings and things like
Yeah,
that,
you obviously can't.
his factory will be ruined. He'll have to take a shutdown for 4 months.
Yeah.
So
So it's a running expansion.
it's a running expansion where it's not just about an electric supply, it's about the indoor air quality being affected.
For sure.
So I cannot have workers or things which create an element of suspended particles in my space or right next to it.
For sure.
So
So
you
it's
know,
also done in the form of silos in a way.
yes. So that's why I talk about thresholds, or it's like a box over a box. So maybe we do a construction of the entire building, but we'll do some services in 70%, we'll do some in 40%, some in 30%, so
For
that
sure.
it's sort of juggling between capital cost and operation cost and balancing it out. And that's where experience really comes in. You know, uh, it it's only with experience that we have started understanding what our clients want and what their future journey will be, and
For
sort
sure.
of calibrating the building to that.
For sure. And do you still see that, of course, with every new project you are learning, but do you see with every new project there is a better technology in the market as well to support? I'm made to believe that fabs were difficult to source earlier.
No. See,
And
I wouldn't be the right person to talk about that.
yeah, for sure.
But in terms of design, the technologies have already always been there. And
What about monitoring?
every year we're getting better at technology, but it's the design which ties it together. And
What about monitoring? Monitoring of parameters. Are these green buildings? Are these?
these are much more than green buildings. I mean,
How?
so in the indoor air quality domain,
Okay.
for everything else in terms of water, materials, etc., if the client wants, yes, we will design even that aspect as a green building.
For sure.
But today's buildings are energy efficient anyway. I mean, we're not we're living in an age where energy efficiency is now ingrained.
Yeah, it should be. Well, let's just not assume for others.
So here we are talking about indoor air quality, and indoor air quality comes as per the specific standards, which are much more stringent
For
than
sure.
in a typical
For sure.
green
And
building.
as an architect, how do you see the scope for learning for students or for people who are interested in sort of coming on board? Because I'm an architect myself. I know that you're not taught these things in the academic courses, and a lot of it is learning by experience, as you're saying. So, anything that our young listeners can sort of look up or try to some case studies that you may suggest or some steps that you may suggest that young practicing architects can take a look at and learn from.
So my only advice here is to start looking at the building as a complete organism. Don't look at it just from the face. So architecture is not just about aesthetics. It's about ensuring that every part in this kit is functioning perfect. Now, it could be a plumbing pipe, it could be an air conditioning duct, it could be a HEPA filter, it could be anything. It could be a compressed air pipeline, it could be your column and your structural elements, it could be your electrical cable, the panel, how each panel is talking to each other, how the
Yeah.
data
So
network is
good
happening.
understanding of services is what you're saying.
Yes, that is what, because when you're looking at these uh, very, very calibrated manufacturing places,
Yeah,
which,
it's a very nicely used, term, calibrated manufacturing spaces. So, as we go towards a close, thank you so much for joining us and for sharing with us these wonderful insights on the design of semiconductor industries. And just to share with you, we are doing a four-part series where we will be inviting more guests for the benefit of our listeners to understand the nitty-gritties of this new age manufacturing, calibrated manufacturing units, which are going to be here forever. And this is the future. So let's hope that we can make our buildings much more efficient, as you're saying, and much more calibrated. Thank you so much, Nishant, for joining us. And as we sign out, let's hope we can bring more guests who can talk about the semiconductor manufacturing facilities, policies, and the kind of norms that are going to go forward. Thank you so much for listening in. Goodbye.